I guess we'll get started with just the preamble here. So my name is Ken Rimple from Chariot Solutions. I'm only serving as the moderator today to keep track of questions and throw them at the guys at the end, and also just make sure things are running smoothly. You can direct message me on the chat if you need to for any questions. And beyond that, welcome to the Lunch and Learn AWS Things I've Learned the Hard Way. Keith Gregory is going to be moderating this, so I'm going to turn this over to him. And again, feel free to use the Q&A in the chat, and I'll turn it right over.
Okay, thanks. So my name is Keith Gregory. I am the AWS practice lead at Chariot Solutions. As an introduction, my background is primarily application development. So I've been professional software developer since the mid-'80s and came into the AWS world about 12 years ago as a tool for enabling software development, and have been working more and more with it and focused on it over the last 5 years or so. And turning it over to Eric for his intro.
Hi there, everybody. I'm Eric Schmidt. I'm the CTO with Moven. We're a financial technology services company based out of the Radnor, Philadelphia area. My background in AWS dates back, to the early days of AWS with the early service launches of S3 and SQS. I've been working as a cloud architect and a champion of AWS services across the board as a real enabler to delivering a set of SaaS-based services to the industry.
Great, and I'm Bill Thompson. I'm the Director of Digital Infrastructure for Lafayette College in Easton, Pennsylvania. I help lead teams responsible for our overall network systems, identity and access management, information security, and our move into public cloud infrastructure in AWS. So we've been migrating systems over the last 2 years or so, and happy to be here.
Okay, I'll take it back. So the point of the webinar today, we described it as things we learned the hard way. And we each have several stories to tell about problems that we either discovered or were able to head off before they became problems, and the lessons learned as a result. And the thing that I'm going to start with is data transfer charges. And they're actually on my mind quite a bit because in one of our sandbox accounts, we had a ECS service, Elastic Compute Container Service, that was constantly repulling its Docker images and ran up quite a bit of a charge, like $10 a day, which for an account that should be doing $1 a day at most in a sandbox was a challenge. But where I really learned about this and learned to look out for transfer charges was several years ago when I was working on a project to move a company's EC2 compute infrastructure, which had been put together before VPCs were a thing, into a VPC, which of course you want to do because of security and simply more control over the deployments. And the standard way to deal with compute in a VPC is you have your load balancers living in a public subnet, able to access the internet and be accessed by the internet. And you have your compute nodes and your database living in private subnets. So they are basically sealed off from everything that is not explicitly permitted access. And if you have a compute node, for example, that needs to talk out to something on the internet, you have a network address translation gateway that basically you route traffic through that, and it handles the interaction with the outside world. So NATs are seemingly very cheap. They have a per hour charge of 4.5 cents an hour and then 4.5 cents per gigabyte, which, for normal applications communicating with the internet really isn't that bad. Well, as it turned out, some of the nodes that we were moving in were pulling a terabyte a day across the internet, which is basically a $50 a day charge, or $600 a month. And we realized that after about a week and had to kind of scramble of how we made this work. And the solution we ended up with was to replace the NAT gateway, which is a managed service in AWS, by a NAT instance, which is an EC2 instance that is configured to act as a NAT. And the reason being, NAT gateways, as I said, 4.5 cents a gigabyte. EC2, any inbound traffic, which was the bulk of our traffic, is free. Outbound traffic is 9 cents a gigabyte. So by doing this, we were able to have a short-term solution. The big problem with our short-term solution is that NAT instances are not managed services. They are EC2 instances which you as the user is responsible, you as the system architect, whatever, is responsible to patch. And if one of them goes down in the middle of the night, you have to wake up and get it running again. And fortunately, that never happened while I was responsible for them. So a couple of lessons learned out of this. One is to not ignore data transfer. Ever since that, I have been very carefully watching data transfer costs with any project I've worked on. The other is that you really have to balance with AWS your trade-off between using the managed services, which are very convenient, very stable, and basically hand building your services, which puts a lot more of the onus of management on you. And when you make that decision, you should make that decision really with a lot of thought, and especially, for example, in the case of our NAT usage, with a plan to get off it, because again, nobody wants to wake up in the middle of the night. So we open this up for questions from people, and also comments from amongst the other panelists. And if we don't have any other comments, I'm looking at my list of stories, and I think, Eric, you're up next.
Yeah, well, before I jump into my first story, just jumping into what Keith was saying there, and another example of that balancing using the highly optimized AWS service that is super convenient, push button turnkey. The example that comes to mind for me is the Amazon Kinesis as a streaming platform versus Apache Kafka run on your own instances. There's a lot of difficulty that you might incur running that infrastructure yourself, but depending on how you're using it, the unit economics of running it yourself on EC2 as a primitive versus adopting the AWS service can be a pretty significant game changer. And I certainly experienced that with my platform.
I'm going to jump in here because I went through that unit economic cost with a project a few years ago where we were having large numbers of basically Kinesis streams. I think it's topics in Kafka. And when I calculated it out, we'd be spending roughly $56,000 a month if we went in Kinesis. Whereas running Kafka, we had, I think, 3 servers that were about $1,500 a month a piece.
Right.
So
yep,
yeah,
exactly.
it's a very interesting trade-off. So sorry.
Yeah, no problem. That was my only real comment there. I'll go ahead and jump into my first story. And the headline of this one is "Don't do your R&D in US East." The subtitle: if you have a workload that you're going to deploy into multiple regions, be very aware of the service catalog that's available in each of those regions. This bit me in an R&D perspective a couple of different times. The first time was really around the launch of the Lambda service. So US East in Amazon region kind of rollout schedule is almost always the first region to see any new features. It's the oldest AWS region out there. And if you assume that all of the features available in US East are going to be there, they might not be when you need to go and run your workload someplace else. So the example there from my perspective was early on, the edges of the CloudFormation service were extensible by using third-party resource customizations that you would write in something like Lambda. Lambda was very attractive there, very low cost, and very easily integrated with that. So we built a system by which interrelated CloudFormation stacks would inform each other of resources within kind of their domain and their container via a Lambda script. Then sold a version of our platform to a customer in Australia. And day one, deploying the solution into Australia, our operation was deploy CloudFormation stack A, B, C, D. When we went to go do that, we were surprised by the fact that Australia did not have Lambda yet. And this pattern repeated itself again as we started adopting Kubernetes in the EKS service. EKS was slow to roll out into some of the more peripheral regions. And our development, again, in US East, blindsided us to that fact, and we had to do some tactical things at the last minute to enable our deployments in those other regions.
Okay, well, rather than jump in with yet another anecdote of the same type, Bill, do you want to talk about your snowball experience?
Yeah, sure. Thanks. So with Lafayette, you know, we started experimenting with AWS. We were looking for kind of an initial real-world, you know, production use case that would be kind of low risk as we were still gaining experience with AWS, and we were presented with a challenge around data storage and archival and preservation. And you know, we had tons of data sitting around that we couldn't get rid of, didn't really need to access it very frequently, but needed to make sure it wasn't going to go anywhere. And of course, AWS Glacier is like the perfect candidate for that, and that was kind of getting our attention. We were also running into sort of capacity challenges on-prem, where we really didn't want to have to deploy more capacity. We sort of had a single tier storage paradigm on-prem, so this was fairly expensive storage system. And anyway, so we started looking at Glacier, and we had about 50 terabytes of data to transfer. So we started looking at these snowball devices. So if you're not familiar with those, they're pretty neat. Amazon ships you essentially a ruggedized NAS device, and plug that in on your network. We were able to transfer all the data to the device fairly quickly. One of the things we discovered or learned the hard way, I guess, is that the device may come sooner than you expect it to. You literally kind of order them like you were ordering something from Amazon.com. And initially, we were led to believe that it might be a long lead time. So we thought we might have had 2 or 3 months for it to show up. And it showed up with like in a week or two. So you have 10 days to transfer all your data. So if you're not ready and prepared in terms of staging your data on-prem or making sure you know what your connectivity is going to be like and network issues are solved and what have you, you could be delayed. After the 10th day, they start charging you on a per day basis to continue to keep the device, which isn't a ton of money, but you know, you don't want to continue to go run over on that. Gratefully, we were still able to transfer our data fairly quickly. Sent that back to Amazon, and in a few weeks, it showed up in an S3 bucket. And our plan was then, once it was in Amazon, to then sort of triage the data. We had a couple different classes or of sets of data. We wanted to sort of reorganize it, get it into sort of separate S3 buckets, getting into the appropriate data lifecycle configuration in S3, and ultimately, for the bulk of it, the majority of it landed in the Glacier. And so what we realized was that, and learned the hard way, was that that's quite expensive to do. You incur quite a bit of network charges to sort of move that kind of volume of data around, even within, in and out of your Amazon VPC. So the real lesson learned there was you really want to have, when you're doing a large data ingest, you really want to have your lifecycle policies and your data organized and your target sort of environment within AWS well constructed and well known ahead of time. That way you can just land the transfer there and not have to move it around and mess around with it once it's up in AWS. I think naively we thought it would be easier to do that when it was in AWS, but and it was fairly easy to move it around and do other things we wanted to do, but it added a few $1,000s to the project overall, which we weren't anticipating. So didn't really blow us out of the water from a budget perspective significantly, because there were still low numbers, but we just weren't expecting it. So it was sort of a surprise for us. And now overall, it's been working great. We have, most of the data is in Glacier, deep storage, and can't beat the total cost compared to what we were doing on-prem.
That data transfer will get you every time.
Yeah.
So you also, I have another note for talking about the single sign-on migration and the registration cycle. So turn over to you for that.
Oh yeah, so this is a fun one. So after we did the initial Glacier data storage preservation archive, we really sort of turned the corner in more of a strategic migration to AWS. And so we've got dozens of workloads there now. And everything was going great. And we had deployed our Lafayette College web single sign-on solution to AWS. It was actually one of the first ones that went. And because we had a really good understanding of that system. It was already in Docker containers, and so we were looking forward to make use of things like Fargate and auto scaling and DynamoDB, and the deployment and the architecture we were really pleased with, and it was humming along just famously. We had done our testing with the auto scaling and actually had seen it work in practice already, and so we were very happy with that. And then along came our first registration cycle for the college, and if anybody who's worked in higher ed always knows that you have this like huge wave, this wall of usage for your student information system and ancillary systems, including web single sign-on, during these registration peaks. And we felt pretty good about kind of where we were. We had the auto scaling, we had it tested, we thought it was going to work well. But it didn't quite behave the way we expected on the first day of registration. So didn't totally fall over, but it didn't really sort of meet our expectations either. And what we saw was that in the auto scaling configuration that we had, the nodes, the Fargate Docker container nodes, essentially couldn't spin up fast enough to meet this wall of usage that was coming at us. And also Fargate was pulling nodes out that looked unhealthy because they weren't getting enough time to sort of spin up. So so a couple of things came out of that. First of all, that in the next couple of days we had gaps. We have 4 registration cycles, so we had a couple of days gap. One was that we were quickly able to spin up a very robust testing infrastructure within AWS. So thank God for that. And we were able to iterate around our auto scaling config to better match sort of what we saw in practice. So that was an amazing sort of experience in and of itself. The key takeaway was that initially we had auto scaling configured to look at CPU as a metric, and also we're auto scaling kind of when the servers were starting to get overburdened. And so what you really want to do is make sure you're auto scaling well within sort of what I would call the green, right? You don't want to wait till you're in yellow, and you certainly don't want to be in red, right? You want to be well within your green when that auto scaling, whatever that metric is, sort of kicks in, and so that you're always staying ahead of the curve. Now for us, we saw this wall coming at us, and so we needed a different kind of metric that had a lot sort of a larger run rate or a larger scale. So for CPU, it was just too short of a time. So we switched over to a metric which was response time per node, the response time per second per node. And so we saw like one node could handle like 1,000 requests per second without even breaking a sweat. And so we used that to dial our auto scaling back down to like, when we see like 400 requests per second, we're going to add another node, and then add another node, and then add another node. And so that way we were able to stay well within the green, and our second registration cycle worked great because of that, but also because I think, and this is probably, maybe this is well known. It seems like it's probably maybe a well-known thing, but if you know you're going to your usage spike schedule, then of course you can pre-allocate some capacity. And so we did a little bit of both. We certainly, in the second registration cycle, we vastly over-provisioned the capacity because we wanted to make sure we weren't going to have any issues. And then we're able to easily sort of scale that back down. And so the lessons learned really are, the hard way was that, auto scaling is a little bit of an art. You definitely want to be able to scale when you're well within the green. And you really need to have an understanding of how long it takes, for that next node or that next set of nodes to come online, because you need enough runtime to bring those on to meet the demand spike.
Yeah, that definitely intersects kind of with one of the stories that I wanted to talk about. That how long does it take a node to come up? If you're in a fully containerized world, you're kind of all in on this immutable image pattern, right? Where the image comes down and it's ready to go, it's ready to start up, it's quick. One of the kind of lessons learned, mistakes made in the past, from my experience was thinking about the way that you approach creating the image for a traditional EC2 based deployment. So EC2 images, standard kind of a configuration where they live in an auto scaling group. The auto scaling targets will cause more of those instances to come online. And the time that it takes those instances to come online can be dramatically reduced if you bake an AMI, an Amazon Machine Image, that has 100% of that instance configuration in it. The mistake that I made was thinking that that was a point where we didn't want to bake everything into that image because it reduced our agility around the image itself. So we built this pipeline that got the image up to a certain state, and then in a launch config, went out and fetched the final artifacts for our services. Thinking that that would give us the ability to quickly, do an update to a microservice that was deployed on this service instance. The reality is, that adds a significant amount of time to the launch. So, when your auto scaling group then is calling for that resource to come online, and especially under high demand situations, you're sitting there waiting for capacity to come online that is taking a lot longer than it should when you have an immediate demand need. So thinking about that, initial delivery and installation process as ahead of a pre-baked AMI dramatically increases that agility in an auto scaling mode. So that was one area that it was a lesson definitely learned the hard way. Another part of that, and this is not an event that necessarily happens on a regular basis, but that pipeline that I'm talking about that was a mistake initially became even more dramatic when there were service issues in S3. So those artifacts that we were installing were living in S3, and we needed to be able to scale, and S3 wasn't available. Hopefully that's not something you run into very often. In my experience, it's a once a year, once every other year kind of an event. But those are the times when everybody on the internet is having a bad day. And if you have baked that into your AMI, you don't have that particular concern. And you could extend that out to any place that you might be doing a just-in-time install. So definitely. The key there is try to make your images immutable and instantly available to respond to those auto scaling events. And then the other thought that I had from Bill's story was, pointing out that he found that CPU wasn't the right metric to trigger auto scaling on. That's one of those things that I think everybody stumbles across and everybody learns. But the documentation available online, everybody talks about CPU as like the metric that you start with. And almost always it's the wrong metric.
Yeah, indeed. Indeed.
Yeah.
Yeah, no, I would concur, particularly on the immutable image side. I mean, getting the launch time down, or at least knowing what your launch time is, and be able to kind of be mindful of that was really a critical thing. So whether it's immutable images in the AMIs or Docker containers, which was what it was for our Fargate, this kind of the lesson's the same. The other part I like about your story is, kind of around the DevOps and the pipeline side, and so this is maybe kind of like a flip of the coin in terms of the immutable image side. We had a story where we were trying to do a transition of a system where our engineering professors had got accustomed to more or less, logging into the server and making configuration changes kind of on an added needed basis in an ad hoc way, with really no version control or backup or what have you. So we had our little pet there, and it was great for the professors because, functionally it met their needs, right? They needed to be able to kind of get on and add stuff and remove stuff and make changes kind of on an as needed basis. And when we were looking to move to AWS, we're kind of like, well, this is not really how it works, right? So we're going to give you an EC2 instance, and if that goes away, then sort of what are we going to do? And so we were able to put together sort of a pipeline build for them where the configuration changes would go into a Git repository. We had kind of a DevOps continuous integration, continuous deployment pipeline where that essentially landed into some sort of user data. And so we did have the sort of the build scripts for the EC2 instances so that, yes, this is actually the auto scaling side. This is kind of the other side where I want it to always come back the same way. I'm not going to build the AMI every time, but I can. So we were able to sort of kind of thread that needle where they still had the power of making changes as they needed, make the Git commit, run the user script, kill the EC2 instance, it would come back again. And so we still kind of had sort of the rollback, roll forward mechanism. And they felt like they still had it sort of the fine gain control that they needed. Without having to learn AWS, right? They didn't have to log into the environment. They didn't have to figure out what an EC2 instance is or what user data was or how the continuous deployment worked. They just needed to add their configuration scripts into a Git repo, and we were able to manage it that way. So kind of a flip side of kind of what you were describing, and it doesn't address with auto scaling at all. But you still kind of remain that control. So there are these instances where you still want that immutable kind of image, as it were. But there are other mechanisms to kind of fill sort of different needs. So I thought that was kind of an interesting kind of analog to your story.
Yeah, and I mean that's the flip side. That's exactly why we landed in the way that we did, and then found that we leaned too far on the configurability side and not enough on the kind of resiliency side on that thing. So it's definitely there's trade-offs on either side of that.
I wanted to riff on the S3 outage a little bit, because that affected us. And I don't think you were quite correct. We had pre-baked AMIs, but those are stored on S3. And we got into a situation where, number one, our assets, which were served from S3 via CloudFront, they wouldn't load, so our users couldn't actually see the website. And when there were problems, we couldn't bring up new instances. And that led us to a lot of soul searching. As you said, S3, it's only gone out once, and the entire internet had a really bad day that day. But it's high availability and what level of work you put into high availability. And it really got us thinking about that because we're relying on high availability within one region. And the assumption there is as long as you're across availability zones, it's the things that are going to take out one availability zone. Okay, someone with a backhoe cuts the main fiber optic cable. So Amazon deals with that very well with multi-availability zones. Something that takes out an entire region, someone getting very upset at Washington, D.C. and dropping a nuke, right? Except someone making an accident in AWS's data centers can also take out a region. But as it turned out, when we looked into it, it's again a trade-off of cost, effort, and benefit. We looked into, okay, cross-regional replication of our RDS database. At the time, I don't think that was a thing, so we would have had to manually configure replication. I believe it is a thing now. Being able to bring up some number of servers without having access to S3 or S3 in a different availability zone, different region, which I think also may not have been a thing back then. I think they may have done regional S3 after that outage. And it's a very challenging, calculation to do. And after spending several hours on it, working through it, we said, you know, if this ever happens again, we're going to have a little virtual host running somewhere in a completely different service that says, all right, we're off the internet, you know, redirect the DNS to it for a while and just accept that we might have 8 hours of no business, but chances are really good that AWS is going to be back online sooner than that.
Yeah, and that goes into kind of disaster recovery and high availability planning in general, right? Every one of those nines is another cost for you.
Yes.
And you know, what's the target? Knowing the target, and then additionally, you know, you highlighted that everybody on the internet had a bad day when S3 was out. You know, how forgiving are your customers when they realize that everything else that they're touching is also having an outage? Is a little bit of a balancing act there. So it was a little less of a black eye for us, just because of the wide-ranging industry impacts across everything that everybody touches.
And it depends, especially, I know your business, you have a relatively small number of clients that are, you have contracts with,
Right.
whereas, you know, something like e-commerce, you have a huge number of clients who use it or don't, that you have no personal, other than doing business with them. So I think there's a lot that you have to think about, the sort of business you do and the sort of contracts you write.
Yep, absolutely. It's really less of a technical conversation at that point and more of a, you know, business risk mitigation conversation.
I was going to jump in. One other thing to riff off of is talking about using CPU as scaling. And this is a lesson that I've learned over time, that when you're running on AWS, you may have an 8 virtual CPU machine with 128 gigs of memory and find out that your own personal laptop runs faster than it in a CPU, especially in a CPU bound, or if you're running a database. And there are a lot of things that go into actual application performance. And this was driven home to me as doing some benchmarks on build servers. And this was part of the idea that it was actually driven because EFS performed, past tense maybe, I need to do another series of benchmarks, very poorly on a build server with lots of small files. But what surprised me is, number one, running on an EC2 instance with Elastic Block Store, you also have the network traffic, which is going to slow down your disk. But running on an EC2 instance with attached SSD was also fairly slow. And it comes down to, what is the thing you're trying to measure? And sometimes you are IO bound, you need to know that. Sometimes you are CPU bound. And sometimes, as in the case that Bill had mentioned, where your network requests are all relatively consistent, you're going to be bound by the number of requests you're making. So I think, yeah, for any planning, it's not so easy as saying, yeah, you know, we can run this app on our laptop with good performance. It's, okay, once we run it in the EC2 or ECS/Fargate or Lambda environment, what is our baseline performance? How well does it scale? And what do we have to tweak to make it perform better?
Yeah, kind of related to that, thinking about, you know, when you choose AWS for your workload, it's kind of an interesting exercise in looking at unit economics for, you know, overall runtime, as well as kind of the parameters of your workload. I remember it's been a couple years back, I was engaged in a consulting engagement with a customer that had a very data heavy IoT kind of an application, and a desire not to do any sort of filtering or reduction of the data ahead of time. So they were really architecting for a solution that was their incumbent solution in a data center where they didn't have a metered storage and data transfer and compute type of a model. So it didn't really look to them like that there was any significant benefit of going to AWS from storing the data from this workload. So it's a little bit of a trade-off, and I think Bill's got some commentary on the total cost of ownership, but that is something that comes up.
Bill, you want to take that?
Yeah, I mean, I think one of the things we've been really trying to kind of think through is that total cost of ownership and how it's sort of changing the way we're deploying solutions and adding value to Lafayette. We used to, I think before the advent of public cloud infrastructure, the technical team here at Lafayette is very strong, and we would always try to find ways to, again, add value, and get the most value for the college. And a lot of times that led us to sort of building solutions on-prem that were good enough for the college, and we're able to add value and save the college money. But we always seem to discount the engineering time and the support time that would go into those solutions. And we never really, I don't think, had great metrics about the sort of total cost of ownership by, what those things cost. And so it's been interesting to kind of walk through, this sort of evolution where, we're trying to get out of these sort of bespoke solutions that did add value in their time, but now really can't compete with the kind of sort of managed services that AWS is bringing to bear, right? I could never pull off the kind of price cost performance that Amazon is providing with something like Glacier, for instance. And we talked for years at Lafayette about, we really should have tiered storage, and maybe we can get kind of another thing in here, and figure out how to do all capacity planning and such and such and such. And to borrow a phrase, you can't fight gravity, and so that's been kind of a real kind of eye opener or culture shift or mind frame shift, around trying to make sure we account for and consider sort of the cost of bringing some of these solutions to bear, kind of in an on-prem or more traditional way versus sort of what we're doing with Amazon now.
When we had talked about earlier, you were also talking about organizational changes that are really needed to support this.
Yeah, indeed, and that's probably maybe even sort of the more important point. For us, we started very tactically, as I said earlier, with the Glacier move, but then we kind of quickly shift to sort of more of a strategic migration where we're really moving the bulk of our workloads, and we had a traditional centralized IT management sort of setup where, systems folks over there and network guys over there and database and we have sort of separate teams managing sort of the various domains. I've been saying now for a while, I feel like we don't even have a systems team anymore, as it were, right? And we kind of had an internal joke, nobody wanted to be the last person, racking and stacking a server at Lafayette, because that probably was a kind of precarious position to be in. And so, we quickly realized we needed to change. We need to change, and figure out how, again, continue to best deliver value to the college. And so we picked up this sort of phrase, that I've used for a long time, that I've borrowed from a previous employer, but, we wanted to take care of the college and take care of each other. And so we knew the structure and organization and management approach of our infrastructure had to evolve to meet these sort of new challenges, because folks were going to have different roles and responsibilities now, and it's not so much about racking and stacking servers and firmware upgrades and storage capacity planning. Like that's taken care of for us now. So, you know, where are we going to add value? And so we've been working sort of with the teams and kind of settled on kind of an overall management strategy. And I'll just share that really, really quickly with you. It's only got 3 components. We have a cloud custodians team, and they are responsible for the overall AWS environment. And so that includes things like billing and cost management, the overall sort of network fabric, account lifecycle, identity and access management, baseline security controls, configuration management, sort of all the things that you have to do to deploy a solution to AWS, but you'd rather not have to worry about. So they kind of handle all those things. So it kind of gives us a platform for all of our solutions deployments. And they operate as a sort of an a traditional service management team. They have routine service requests and operational tasks and incident response and so forth. The second component is what we call our cloud deployment committee, and it's sort of our center of excellence. These are the folks that have gained deep expertise in AWS. They're sort of our solutions architect team, and they provide a discussion and forum for reviewing architecture, deployment plans, solution security plans, and give feedback to the third component, which is our individual solution hosting teams. So those solution hosting teams traditionally were really just focused on sort of what I might call application administration. Like, how do I deploy a particular software package, and how do I configure it, and how do I support my end users, and how does it plug into the infrastructure that's available to me. But now with AWS and public cloud infrastructure, the infrastructure is whatever it needs to be to support the application. So now the solution hosting teams have sort of a broader responsibility for the infrastructure, the public cloud infrastructure that's specific to their solution. And so this overall framework's been working really well for us. We were trying to kind of strike a balance between enabling the solutions hosting teams to move quickly and be agile and to adopt solutions that fit their workloads well. But at the same time, we wanted all the solutions hosting teams to kind of move in a somewhat a coherent and consistent way. And so that's what we get out of the Center of Excellence, the Cloud Deployment Committee. And then that overall dynamic is supported by a solid platform for network connectivity and security controls and account lifecycle by the cloud custodians. So, that sort of organizational transformation was really, I think, critical to our success. And the whole thing is really, you can have great technology, but you have to have the right teams and the right structure in place. And so all of this has been supported by AWS Control Tower, which is sort of enabled sort of this multi-account management strategy that we've put in place. So yeah, I guess I don't know if there's a lessons learned there or lessons learned the hard way, other than to say you really need to give some thought to sort of your organizational strategy and sort of roles and responsibilities once you make sort of a more kind of strategic move in terms of, kind of a big migration.
I think that's actually probably a lot of lessons learned there. One thing that jumped out to me listening to you talking about it is that your applications team seemed to have really fully adopted the idea of being responsible for infrastructure as well as just programming. Is that correct?
Yes, and I'd say there's that's probably where there's the most variability in the sort of overall structure, because we have some solution hosting teams who, because of any combination of sort of aptitude or skill or desire, or even the workload itself might be, lends itself to sort of making use of some of the managed services in AWS. So there's sort of a lot of motivation to get a sort of deeper appreciation and understanding. So we have some solutions hosting teams that sort of fully embrace that model, where they're responsible for the part of the public cloud infrastructure that is necessary for their workloads. In other cases, and again for a variety of reasons, we might supplement those solutions hosting teams with somebody from the Center of Excellence or perhaps the cloud custodian team to kind of give them a leg up, both in terms of expertise and experience, but also to sort of basically supplement that team. Because in some workloads, they don't really care so much that whether it was on-prem or in the cloud, they still need their VMs. They don't really care whether they were VMware or EC2 instances. They just want to know how do they get access in this new paradigm and do the work they were already doing. So we want to try to give them a little more visibility into the public cloud infrastructure part of their solution, but in some cases still kind of provide that kind of managed service from an infrastructure perspective. So we have a little bit of variability there, but we do like to sort of, where there's opportunity to lean towards that scenario where the solutions hosting teams do really take on kind of sort of a broader role and responsibility in terms of the infrastructure required.
Yeah, so beyond just the organizational aspects of that, kind of intersecting that with the AWS service portfolio and its evolution over the years. You mentioned control tower, organizations, the linkage between accounts, allowing you to do an account per whatever unit you have within the organization. Those are things that have really matured in the last couple of years, and it's one of the things that I love about working with AWS is that they continually solve for pain points and continually improve that solution set.
Yeah, I mean, I couldn't agree more. And one of the things we're trying to kind of institute into the overall management is these sort of architecture reviews. Because you're going to deploy a solution, and then 6 months, 6 weeks, 6 days, 6 hours, I don't know. I just know it's coming. That the solutions that you're building upon are going to kind of evolve, because we've all seen that over time. But then there's going to be new solutions that are brought to bear, that address some pain points. So one of the things we're trying to do, kind of as a best practice, as it were, is kind of that continuous improvement on the solutions hosting teams, that kind of schedule or review with them in terms of what their deployment architectures look like from time to time. The other thing you're reminding me in terms of the, our overall sort of like multi-account management strategy, that was, I don't think we kind of anticipated. I don't think it was really sort of planned in, as it were. But we've taken the strategy where all the workloads are really isolated per account. And this makes sort of the cost accounting and cost management like super, super easy, particularly with the current Cost Explorer and the AWS console. We review this sort of, weekly and then monthly in our cloud custodians team. I can tell you now on a per workload basis, what they're using, what the costs are. And that's been a real eye opener, and previously, we were all deployed on sort of this common on-prem infrastructure that was, because for capacity planning reasons, was way over provisioned. And I really had no way to easily say, oh yeah, our web single sign-on costs us, $150 a month to run it on-prem. I could make some guesses and we could do some sort of gross, summaries and that sort of thing. But now I can tell you, basically down to the dollar, sort of what those workloads are costing, which is really cool, because it puts sort of a cost engineering new kind of role and responsibility across the teams. But it also makes sure that, again, sort of adding value to the college, that, is this workload really, does it really cost this much? It does. And is that really, valuable? Do we still really want to do that? And it allows the service teams themselves just kind of greater visibility about sort of what we're doing. So that's been a real huge help and a big game changer for us.
Yeah, I think one of the themes that I think we've identified in this conversation, several of the things have been cost related. One thing that I don't think any of us mentioned was putting guardrails around those costs. AWS provides budgeting alarms that you can very easily enable. So if hey, I don't want to get over this amount and I want to be cognizant of that, it's very, very easy to put those budget alarms in place so that you don't get surprised. And I think that's one of the kind of defensive measures that you can deploy very easily.
I'll chime in, agree totally on that. Budgets, and especially with the multiple account structure at Chariot, as consultants, we have multiple accounts set up that we basically associate with a project team. And you want to give the project teams the ability to have the flexibility to do whatever they want, but you also don't want to be burned by it. So I've really grown to love service control policies, budgets, and Cost Explorer, just for tracking down and saying, oops, guys, you know, you've spent a few $100s this weekend that, did you really need to have all those machines running? So, so very much agreed. It's all about paying attention, I think.
Yeah, and that projected budget, the projected spend is really helpful there too, because you get, it's not, you know, oh hey, you just hit the mark. It's you're projected to hit the mark.
Right, right. Unless either of you have more comments or things you'd like to talk about, we do have one question that I can throw out. The question is, and this is a fairly technical question, other than response times, what other metric do you commonly use for scaling triggers? Or for scaling triggers, shouldn't have put the pause there. I'm going to throw out a hot take on this and say that in a lot of especially web-oriented applications, time is a very important scaling trigger. If you know that your business has peak load times between 8 and 10 in the morning, let's say, Eastern time, I found that it's very useful to say, okay, we will load up our number of web servers for that time as a explicit, I can't remember their term for it, but number of instance scaling policy, and then we'll back down after 10 o'clock based on actual usage.
Yeah, I think there's a maturity model that goes along with, you know, the science and art of auto scaling, and I think there's no early enough time to jump in there and understand that a static set point isn't necessarily the right place to do. You know, you do a static set point based on your peak workload, you're going to spend way too much for your infrastructure. So clock schedule, absolutely great. When you get further down that maturity model, you know, tactically answering that question, or what do you use as an auto scaling metric? Understanding your workload is very, very important there. You know, there are different execution models that can drive that. So if you think about threaded application programming, where CPU is more useful as a metric versus evented application programming where IO is much more useful as a metric, there's, you know, that is kind of the science that you need to get down into. So, you know, a request basis is a very great metric. I think that's what Bill was talking about. You know, one of the common ones that I use in my environment, actually the two common ones that I use in my environment are the Node.js active requests metric. So it's introspecting into the runtime of the application and seeing how many active requests are going on. So not necessarily from an HTTP request perspective, but from what the workload is in the actual engine that's running your code. And the other metric that we use for a lot of our asynchronous workloads that auto scale is the lag in the message queue. So we use Kafka heavily, and knowing how far behind real time you are in an asynchronous workload is a great way to size your scale. So then you can have an auto scaling group that when there's no lag, appreciable lag at all in the system, you can scale down to, you know, essentially down to 0, and then quickly scale up as delays build in that queuing system.
Yeah, one of the things that I think ties into that, and you've been talking about lots of different metrics, making your applications observable. Out of the box, AWS gives you a bunch of CloudFormation, CloudWatch metrics that you can track, but you can add on to those, as you were describing, looking into the Node.js process to extract information, and you can create custom metrics. One of the things that I remember one project I was on, I said, let's just turn on the access logs for the load balancer. And then after we had a week or so, I said, let's run this little Athena query and see what our top 10 requests are. And it's eye-opening. Being able to look at that and then you turn around and you start to think, okay, what could I look at? What could really help me? So I don't see any other questions, and we're getting up to the end of the lunch hour. If either of you would like to say anything, by all means. Otherwise, I'm going to turn it over to Ken to wrap up.
No, I think I'm all good. Thanks for the opportunity to get online and chat.
Thank you for coming.
Yeah, same here. This has been a lot of fun, and hopefully it was useful for some folks. I think I would say for anyone who's sort of new to it or trying to get into AWS, I think you know, for us the experience has been great, and you just need to start. I think if you just get started, you know, if you can find like a tactical workload that's low risk, just get it, you know, just work it through. You're going to learn a lot. And it's going to lead you into sort of, you know, deeper experience. And so, yeah, I think for us, it was just getting started, and been a lot of fun and been really helpful.
Great. Yeah, and speaking of someone who likes to trip Keith's CloudWatch billing alarms, thank you for the information. Yeah, so we will have this all put on a video for later, and probably a podcast episode as well, because this is perfect for an audio stream. So look at Chariot Solutions' Twitter account, that's @Chariot Solution, or on our website on the resources tab for the information. And again, thanks to all three of you for this great panel discussion today.
Thank you.
All right, take care.
See y'all.
Thanks a lot.
Bye-bye.